Sketch the graph of the polynomial function p of x equals negative 2x to the fourth minus x cubed plus 3x squared. The first thing we do here is we look at our leading term to get our end behavior. So starting with our leading coefficient, we have negative 2. So the leading coefficient is a negative number. And a negative leading coefficient means that the right side of the graph goes down. That means y approaches a negative infinity as x approaches infinity. The next thing we look at is our degree, and the degree here is 4. Okay, and that's an even number. And an even degree means that the left side does the same thing as the right side. So since the right side went down, the left side will also be going down. So y approaches negative infinity as x approaches negative infinity. Okay, then we need our factored form of our polynomial. So I'm going to start off by pulling out an x squared, which each of these has in common. And I don't like having a leading negative, and so I'm going to pull out actually a negative x squared out. Okay, and we're left with a 2x squared plus x minus 3. Okay, and then we have a quadratic here that we can factor some more. And that will be, we've got a 2x, let's see, a plus 1, and then, oh, sorry, let's see. We'd have an x here, and then let's see, a minus 1 and a plus 3 here. And so now we can set each of these equal to 0 to get the zeros of our polynomial. So if we set this first one here equal to 0, we just get x equals 0. And that has a multiplicity of 2 because the exponent is 2. And then setting this factor equal to 0, solving for x, we get x equals a negative 3/2. And that's a multiplicity of 1 because the exponent on that is 1. And then finally, this last factor we set equal to 0, solve for x and get x equals 1. And that also has a multiplicity of 1 because the exponent on that factor is 1. And remember, the multiplicity tells us what the graph looks like at around that 0. So a multiplicity of 2, it looks like an x squared function. It looks like a quadratic. Okay, and then for a multiplicity of 1, that looks like x to the 1, which is just a line. Okay. And then we draw our end behavior. So on both sides, we're going down. And then we can plot our zeros. So we've got a 0 at x equals 0. And we've got a 0 at negative 3/2. So that's 1 and 2. 3/2 would be right around here, negative 3/2. And then we have x equals 1. So right around there. And then we are ready to draw our graph. We just start at one of our end behaviors. We go through. We know what we're going to cross here at negative 3/2 like a line. Okay. Then at 0, we act like a quadratic, so that looks like a parabola. Okay. And then pass through the 1 like a line as well. And that's a sketch of our polynomial.